Welcome to Paradox Lab. Have you ever looked up at the night sky and wondered why it is as pitch black as ink? This is not a silly childhood question, but rather a deep chasm in the foundation of physics that has spanned centuries. If the universe is truly infinite and teeming with brilliant stars in every corner, the sky should be as blindingly bright as the surface of the sun at all times, regardless of whether it is day or night. In truth, hidden behind that darkness is a terrifying secret about the very nature of the space and time surrounding us. Hello, I am Paradox Lob Guy. Today we will decode the mysteries of light and darkness together through Olbers Paradox. Stay tuned until the end to discover the astonishing revelations of this paradox that will completely alter our perception of the true nature of space. If you love science and the mysteries of the universe, please subscribe to the channel to support us. Thank you so much. The stillness of the dark night seems to be the most obvious thing you have ever experienced. Yet, for scientists, it has been a perplexing puzzle without an answer for hundreds of years. Let us travel back in time together to understand why that darkness is so terrifying. Imagine you are standing in the middle of a dense forest, so vast that it has no borders. Whichever direction you look, your line of sight will eventually strike a tree trunk, leaving no gaps for you to see the empty space beyond the forest. If we replace those tree trunks with stars and the forest with the universe, a similar logic applies. If the universe is infinite, then in every direction you look from Earth, your gaze must inevitably touch the surface of some star. This means the entire night sky should be brilliantly illuminated, without a single crevice for darkness to seep through. This paradox is named after the German astronomer Heinrich Wilhelm Olbers, who systematically presented it in 1823. However, the seeds of this doubt had been sown since the times of Johannes Kepler and Isaac Newton. In the classical cosmological model, it was believed that the universe was static, infinite, and had existed for eternity. If these assumptions were true, the light from the most distant stars would have had ample time to travel through space and fill every void in our sky. But in reality, as you can see, the night sky still bears a mysterious and lonely blackness. This directly declares that something in our understanding of the universe is severely flawed. You might wonder if distance causes light to weaken. It is true that light from a distant star will be weaker than from a closer one, according to the inverse square law. However, in an endless universe, the number of stars at greater distances increases in proportion to the square of the distance, perfectly compensating for the decrease in light intensity of each individual star. The ultimate result would still be a blindingly fiery sky. This leads us to the first shocking revelation in scientific thought. The darkness of the night is not the absence of light, but rather eloquent evidence that our universe has a limit, or is undergoing a violently drastic change. One of the earliest attempts to explain this was the cosmic dust hypothesis. It was thought that colossal dust clouds obscured the light from distant stars. But according to the laws of thermodynamics, this is a flawed explanation. If dust absorbed light for an infinite amount of time, it would gradually heat up until it reached the temperature of the star itself and begin to glow just as brightly. Therefore, dust cannot be a permanent curtain hiding the light. To decipher this mystery, we must touch upon a fundamental concept of modern cosmology: cosmic inflation and the Big Bang. The universe has not existed forever. Modern measurements reveal that it is only about 13.8 billion years old. This is a colossal number to humanity, but it is merely a blink of an eye for light that must travel from the deepest reaches. Light from stars located beyond a radius of 8 billion light-years simply hasn't had enough time to reach your eyes. This is the very concept of the observable universe. We are living in a finite bubble of light, and outside that bubble lie regions of space where information is still journeying toward us. Let's think about this more profoundly. When you look up at the sky, you are not just looking into space, but you are looking back in time. What you see is the universe's past, and if we look far enough, what will we see? Scientists used the Hubble Space Telescope to conduct a specific observation, known as the Hubble Deep Field. They pointed the telescope at a patch of sky that appeared completely dark and empty for many consecutive days. The resulting image shook the scientific community. Thousands of radiant galaxies emerged from the deepest darkness. This proves that light is everywhere. Yet why is it still not enough to illuminate the night sky? The answer lies in an even stranger truth. The universe is expanding. This expansion is not just galaxies flying apart from one another, but space itself being stretched out. As light travels through expanding space, its wavelength is stretched out, a phenomenon known as redshift. The light from the most distant stars and galaxies has been stretched to the point where they are no longer in the visible light spectrum, shifting instead into the infrared or radio wave regions. Let's talk about the cosmic microwave background radiation. This is a complex cosmological concept, yet it is the key to understanding the radiant truth of the sky. If human eyes could see radio waves instead of visible light, you would find that the night sky is not dark at all. Instead, it would shine uniformly bright in all directions with the halo of the Big Bang, a thermal afterglow from a time when the universe was merely 380,000 years old. But because our eyes are limited, we only perceive a silent blackness. However, do the explanations of the universe's finite age and its expansion truly solve Olbers Paradox completely? Or are we simply trying to piece together fragmented puzzle pieces into a model that we ourselves are not yet certain of? If the universe continues to expand forever at an accelerating rate, will all the light from distant galaxies one day vanish entirely from our sight, leaving behind an eternal and lonelier darkness than ever before? The darkness you see tonight may not just be a result of the past, but also a warning about the future of a universe tearing itself apart. Is it possible that there are worlds where the night sky is truly radiant? Or are we the only creatures imprisoned in an illusion of darkness? Now, let us step deeper into the darkness to find the answer to an even more haunting question. If the universe is truly immeasurably vast, could it be that light is being imprisoned by time itself? You see, light does not travel instantaneously. Although it is the fastest thing in the universe with a speed of approximately 300,000 kilometers per second, on the terrifying scale of space, light is like a snail crawling slowly across an endless field. This is the first key to peeling back the mysterious veil of Olbers Paradox. When you look at a star 10 light-years away, you are not seeing it as it is in the present, but rather its image from 10 years ago. This leads to a shocking conclusion. The night sky you see is actually a graveyard of the past, where rays of light are desperately trying to tell the story of what happened millions, even billions of years ago. Imagine the concept of the cosmic horizon. This is not a physical wall surrounding us, but a limit of observation. Because the universe is only 13.8 billion years old, we can only see objects whose light has had enough time to journey to Earth within that time frame. Stars beyond the 13.8 billion light-year range still exist and are still radiant, but to you and me, they are completely non-existent. Their light is still on its path, tirelessly crossing empty voids of space, having never yet touched the human eyeball. If you consider the universe a giant stage, we are merely sitting in a narrow halo of light, while the rest of the play remains in dense darkness because the light from that stage hasn't reached our audience seats yet. But there is another, harsher reality that few think about. Stars are not eternal. Even if the universe is infinite in space, it is not necessarily infinite in time and matter. A star is like a candle. It needs fuel to burn. They are born brilliant for a few billion years, then fade away. For the entire night sky to shine as bright as the sun's surface, we would need an unimaginably massive number of stars, and they would all have to shine simultaneously. In reality, however, stars have finite lifespans. Before the light from extremely distant stars can reach us, the closer ones may have extinguished long ago. This lack of synchronization creates dark voids in the sky. You are looking at an unfinished tapestry, where the threads of light are severed by the deaths of galaxies and the belated beginnings of new suns. In 2022, the James Webb Space Telescope, a technological marvel of humanity, sent back data that completely changed how we view the dawn of the universe. It observed the most ancient galaxies, notably one named JADES GSZ13-0, which existed just 320 million years after the Big Bang. The shocking thing here is that these galaxies appeared too perfectly formed and radiant compared to what current physical models predicted. Why did they appear so early? Why were they so bright? These specific observations from James Webb are challenging our beliefs about the so-called cosmic dark ages. If light was present so strongly from such an early time, why didn't it fill space? Is there some mechanism actively swallowing light or preventing its spread? This is when doubt begins to sprout in the minds of the sharpest observers. Are we wrong to assume that light always travels in a straight line and retains its energy over billions of years? Some fringe theories have questioned whether light gets tired along the way. Although the tired light hypothesis has been rejected by the vast majority of the scientific community, the existence of dark matter and dark energy remains the phantom haunting all our calculations. Have you ever wondered if 95% of the universe is made of things we cannot see, cannot touch, and do not interact with light? Then is the darkness you see in the sky truly empty? Or is it actually an invisible ocean of matter enveloping isolated islands of light? We often believe in the Big Bang model as a single starting point, a singularity where everything began. But let me pose a bold open question. What if that so-called starting point is merely one phase in an eternal cycle? If the light from previous cycles had completely dissipated before the new cycle began, then the darkness of the night is the remaining trace of a massive-scale destruction. Every time you look into the voids between stars, you might be peering into the abyss of dead universes where time has erased all traces of life and light. Another shocking thing you must ponder is the connection between the universe's expansion rate and the event horizon. Imagine you are trying to run toward a friend, but the ground beneath both of your feet is stretching out faster than your running speed. You will never, ever reach them. Light faces the same fate. The universe is expanding at an accelerating rate, and at extreme distances, space is stretching faster than the speed of light itself. This means there are regions of the universe from which light will forever be unable to reach us. Even if we waited trillions of years, we are being isolated on a shrinking island of light amidst a vast ocean of darkness. The dark night you see is not a flaw of nature. It is a protection. If Olbers Paradox did not exist, if the sky were truly as blinding as the sun, life on Earth could never have formed. We would be roasted alive in a giant cosmic microwave. Darkness is the cradle that allowed life to sprout and evolve. But that cradle is also a wall separating us from the panoramic truth of the universe. Will humanity ever overcome the limits of light and time to see through what lies beyond that cosmic horizon? Or will we forever remain creatures standing in the dark, looking at the flickering rays of the past, and deluding ourselves about a complete understanding? When you close your eyes tonight, remember that darkness is not nothingness. It is a veil hiding a reality that our intellect is perhaps not yet ready to face. The isolation I just mentioned is not just a distant hypothesis. It is happening right now in every millimeter of space surrounding you. To understand why light vanishes so mysteriously, we must confront a shocking truth. Space is not a silent stage for stars to perform, but it is like a rubber sheet being stretched out infinitely. This is exactly where the concept of cosmic redshift comes in and completely changes the game. Imagine light as a slender rope connecting a distant star and your eye. As the space between those 2 points expands, the rope of light is stretched tight. When pulled tight, the wavelength of light becomes longer. If pulled hard enough, visible light, inherently vibrant in color, transforms into infrared rays, then radio waves, and ultimately disappears completely from the perceptive ability of the human eye. The night sky you see is a deep black, but that is a visual lie. If you had the eyes of a creature capable of seeing radio waves, the night sky would never be dark. It would be radiant, blinding, and so flooded with energy that you could not see anything else. This leads us to a shocking moment. We do not live in a dark universe. We are simply creatures blinded to the vast majority of its most brilliant light. The expansion of the universe acts as a massive filter. It systematically turns off the lights by pushing rays of light into the invisible realm. This is not just a loss of light, it is a loss of information. With every passing second, a massive amount of data about distant galaxies is forever crossing the threshold beyond what the naked eye, and even optical telescopes, can reach. In 1929, Edwin Hubble made a specific observation that altered the entire flow of astronomical history. He discovered that, with the exception of a few neighboring galaxies, most other galaxies were moving away from us. And strangely enough, the farther away a galaxy is, the faster it recedes. This is not normal movement through space, but space itself bulging out everywhere. Think about this. If you stood on a balloon being inflated, every point on the surface moves away from you. But at great enough distances, the expansion rate of space can exceed even the figure of 300,000 kilometers seconds. This means light from those regions of space is trying to run toward us, but the ground beneath its feet is receding faster. That light is trapped in a race it is destined to lose. And as a result, those regions of the universe will forever sink into darkness for us. This expansion poses an agonizing open question regarding the law of conservation of energy. When light's wavelength is elongated due to redshift, the photon's energy decreases. So, where did that lost energy go? In a static universe, energy must be conserved. But in an expanding universe, according to general relativity, the answer is no longer that simple. Is the universe gradually cooling down and slowly losing its vitality as it stretches itself? If the light from every star is weakened by this expansion, then the darkness you see is the sign of a universe exhausted of its energy. Another shocking realization arises when we consider the density of photons. Even if light were not redshifted, the expansion of space also dilutes the density of light particles. Imagine you have a room full of light, and suddenly that room expands a billion times. The particles of light would be scattered so far apart that the probability of a photon hitting your eye becomes extremely low. The night sky is pitch black because light has been diluted in an ocean of space that is far too vast. We are standing on a small island, trying to search for grains of light sand amidst an endless, ever-expanding void of a desert. Do you ever shiver thinking that we are living in a special era of cosmic history? If we had lived billions of years ago, the night sky might have been much brighter because galaxies were closer together and redshift was not strong enough to obscure the light. Conversely, if we were born trillions of years from now, expansion would push every other galaxy out of our observable horizon. By then, even the most powerful telescopes would see nothing but absolute darkness. Future inhabitants of Earth will think the universe consists solely of their own galaxy, and Olbers Paradox will no longer be a paradox, but an indisputable, self-evident truth. The darkness you see today is actually a privilege, a reminder that we can still see our cosmic neighbors before they disappear forever into nothingness. The concept of cosmic inflation also plays a crucial role here. Right after the Big Bang, the universe underwent an extremely rapid expansion phase, faster than anything we can imagine. This phase pushed matter and light so far apart that it created massive voids. The empty spaces between superclusters of galaxies are not places containing nothing. They are places where light was swept away by that storm of expansion. When you look at a pitch-black patch of the sky, you might be looking at a scar from the inflationary period, where space was stretched to the point that not a single ray of light could fill it. Is there a boundary where expansion will stop, or will space continue stretching until even the atoms in your body are ripped apart? The darkness of the night is not just an optical issue. It is a measurement of the universe's dynamism. We are observing a reality in motion, a reality where light is desperately fighting against the expansion of nothingness. Whenever you see a twinkling star, remember that its light had to overcome the horrendous barriers of expanding space to reach you. It is a survivor, and the darkness surrounding it is the testament to the failure of countless other rays of light that could never complete their journey. The truth about darkness does not lie in what we see, but in the invisible force silently erasing light from the map of reality. As we delve deeply into the nature of darkness, there is a seemingly very logical argument that many people, including Heinrich Olbers himself in the 19th century, once entirely believed to resolve this paradox. That is the presence of interstellar dust and gas. Imagine the universe as a city enveloped in dense fog. No matter how bright the streetlights are, the fog layer will absorb and scatter the light, causing distant objects to become hazy and ultimately disappear completely. Could it be that the darkness you see in the night sky is simply a massive curtain of matter, hiding the brilliance of billions upon billions of stars behind it? This is a fascinating idea, but it harbors a fatal physics flaw. When you realize it, you will see the universe is far harsher than we ever imagined. To understand why the curtain of dust cannot be the answer, we must touch upon a fundamental principle of cosmology and physics: thermodynamic equilibrium. Think about an oven. If you put a piece of metal inside and turn the temperature up high, the metal might initially be dark. But as it absorbs enough thermal energy from the oven, it will start to heat up and eventually glow red hot, radiating a temperature equivalent to its surroundings. Cosmic dust behaves identically. In an infinite and eternal universe, these dust clouds would endlessly absorb light from the surrounding stars. Over time, they would heat up until they reached the temperatures of those very stars. At the point of equilibrium, the dust would radiate intensely, exactly matching the amount of light it absorbed. Instead of hiding light, this dust layer would become a colossal light source stretching across space. Therefore, the fact that the sky remains pitch black is ironclad evidence that the universe cannot possibly be in that state of eternal equilibrium. The truly shocking moment emerges when we look at regions of space known as massive voids. There is a specific region called the Boötes void, a colossal area with a diameter of about 250 to 330 million light-years. Imagine a spherical space so massive that if our Milky Way galaxy were located at its center, we would not have known about the existence of any other galaxies until the 1960s. This is a region of near absolute nothingness, where the density of galaxies is astonishingly low. Why do such grand and dark voids exist? If the universe is homogeneous and infinite as older models predicted, these holes shouldn't exist. Their presence raises a massive question mark. Is darkness an active component structuring the universe, rather than just the absence of matter? Scientists used the Spitzer Space Infrared Telescope to make specific observations of the densest dust clouds in our galaxy. The results showed that inside those dark and frigid clouds, thousands of new stars were forming. However, more importantly, the data showed that cosmic dust actually radiates powerful infrared energy. This confirms that dust does not silently swallow light. It only converts energy from one form to another. If we could see heat, the sky would look like a chaotic, blindingly colorful canvas. But the reality is that it remains black to the human eye. This once again affirms that light is not blocked by matter, but is governed by something far more powerful: the age and expansion of space itself. Let me walk you through another aspect of the misunderstanding about darkness. Many believe that because stars are so far away, their light cannot reach us. But you must remember that in an infinite universe, the number of stars will increase exponentially as we look further out. Every time you double the distance, the surface area of the observable sphere quadruples, and the number of stars increases accordingly. This increase in number perfectly offsets the decrease in light intensity over distance. Mathematically, if the universe were infinite and static, the night sky must be tens of thousands of times brighter than the sun at noon. The fact that this does not happen leads us to a profound skepticism about the nature of infinity. Perhaps infinity is merely a mathematical concept, while our reality is locked inside a finite cage of time and matter. This leads to a second shocking realization: the existence of dark matter. We know there is a massive amount of matter that doesn't emit, absorb, or reflect light, making up about 85% of the total matter in the universe. Does dark matter play a role in Olbers Paradox? Although it doesn't interact with light conventionally, it has mass and generates gravity. This gravity bends light, creating the phenomenon of gravitational lensing. Light from distant galaxies can be bent, scattered, or focused onto specific points, creating an uneven map of light across the sky. The darkness you see could be the result of light being redirected by these colossal phantoms of dark matter lurking in space. So if dust is not the cause and vast distance is not the sole reason, what is truly keeping the night sky peaceful? There is a shocking truth that few dare to face. We are living in a universe that is slowly dying in terms of light. Astronomers have observed that the rate of star formation in the universe peaked about 10 billion years ago and is currently declining. The universe is consuming its fuel faster than it can replenish it. One day, all stars will die out, and the darkness we see now is merely a prelude to an eternal blackout. A haunting open question emerges. If we could completely strip away every layer of dust and every particle of obstructing matter, would we see a more brilliant universe, or would we simply see a deeper abyss of nothingness? Is darkness the natural state of the universe, and light merely an accidental and rare glitch in an eternal dark ocean? The persistence of the dark night is not a mystery to be solved by adding curtains, but a silent scream of the universe regarding its own finiteness. When you stand under the night sky and feel the coldness of darkness, remember that it is not because light is obscured, but because we are witnessing the final frontier of what can possibly exist. The misconception about dust taught us a vital lesson. We cannot use conventional notions to explain phenomena on a cosmic scale. We need more powerful tools, theories that shatter all boundaries of intuition. And as we move into the next part, we will discover that even in absolute blackness, there actually exists the most ancient, most radiant kind of light, yet it is hiding right before our eyes. It is the light of the beginning, and possibly the light of the end as well. The darkness you are viewing is actually the greatest optical illusion in human history. If you could peel away the masking limits of your mortal eyes, you would be astonished to realize that the night sky is not dark at all. On the contrary, it is burning with a blinding halo, filling every millimeter of space from every direction. This truth leads us to the ultimate and most astonishing resolution to Olbers Paradox. We don't see a brilliantly bright sky not because the light doesn't exist, but because that light is far too ancient, coming from an era when the universe was still a dense and scorching ball of fire. This is the concept of the cosmic microwave background radiation, a surviving trace from the dawn of time. Imagine the time around 380,000 years after the Big Bang. Before that moment, the universe was a scorching hot plasma soup, so dense that light could not move freely. Photons constantly collided with charged particles and were imprisoned in an eternal haze. But then, a momentous event occurred when the universe cooled down enough for the first atoms to form. Suddenly, space became transparent, and for the first time in history, light was freely released to journey across the cosmos. Those light rays have traveled for 13.8 billion years to reach us today. However, on that epic journey, the expansion of space itself stretched their wavelengths from blinding light into ultra-short radio waves invisible to the human eye. To verify this, humanity has conducted incredibly sophisticated specific observations. The most prominent is the data from the Planck satellite of the European Space Agency, launched in 2009 and publishing a detailed map in 2013. This satellite scanned the entire sky to measure the most minute temperature fluctuations in that ancient background radiation. The map Planck returned did not show an empty blackness, but a colorful canvas of the very first seeds of matter. It proved that everywhere you look, even in the darkest voids between cosmic structures, is constantly flooded with light from the distant past. Darkness is merely a perfect camouflage of physics against biologically limited creatures like us. But right here, a massive doubt regarding the current cosmological model arises. If we rely on the Hubble constant to measure the rate of expansion, different measurements yield different results, creating a contradiction known as the crisis in cosmology. This forces us to ask an unsettling open question. Is expansion truly happening the way we think it is? If dark energy, the force pushing galaxies apart, suddenly alters its nature in the future, will darkness completely swallow whatever is left of the light? We may be living in a brief golden age, where darkness and light still exist in a fragile equilibrium just so we can observe and ponder. Imagine a distant scenario. Trillions of years from now, when expansion has pushed every galaxy beyond our observable horizon and even the microwave background radiation is stretched until it dissipates into nothingness. By then, the night sky will truly be an absolute black without a single ray of light, without a trace of the past. The creatures born in that era will have no way of knowing they are in a universe that once possessed billions of radiant galaxies. They will live in an eternal deception of darkness. Olbers Paradox will then no longer be a scientific puzzle, but a frozen reality, halting all attempts to discover the origins of existence. Standing before the vastness of the dark night, we feel immensely small. But that very darkness is our greatest teacher. It teaches us that reality is not always what meets the eye and ear. Every time you look up at the sky and see a pitch-black void, do not feel lonely. Remember that it is the place where light is hiding, where the secrets of 13.8 billion years ago are still silently vibrating. Darkness is a protective veil, but also a challenge to the human intellect, urging us to look further and deeper into the essence of reality. The awe we hold for the universe does not come from knowing everything, but from realizing we are standing amidst a hidden ocean of information. The darkness of the night, a paradox that seems so simple, is actually the doorway leading us to touch the origin of all things and the ultimate destiny of time. We look into the darkness to find the light of knowledge, and in that seemingly empty space, we find the story of ourselves, specks of stardust, trying to understand the magnificent home that envelops us. A sense of unease creeps in when realizing the limits of observation, but simultaneously, a radiant hope flares up because we have had enough courage to ask questions about the most obvious thing. Why is the night dark? The universe will always keep for itself mysteries that can never be fully decoded, and perhaps that is its beauty. A brilliantly shining sky might give us clarity, but a pitch-black night sky gives us curiosity and the thirst to conquer. We are wanderers in the dark, using the light of thought to illuminate the path in search of truth. And no matter how vast the darkness is, as long as we keep asking questions, the light of intellect will remain present, flickering yet enduring like the most distant stars in the cosmic horizon. Thank you for accompanying Paradox Lab on the journey to decode the limits of knowledge. If these mysteries stimulate your curiosity, and if you believe we should question everything, please hit the subscribe button and turn on notifications so you don't miss the next videos. The darkness of the night is not the end, but a new beginning. Every question you pose is a new star ignited in the sky of knowledge. Keep exploring, keep being curious, because we are humans capable of understanding the universe, and that is what makes us miraculous.